All right, let's get right into it. Today, we are diving deep into what it really takes to jump from being an AI practitioner to a true AI architect. We're going to uncover some of those critical blind spots that a lot of engineers have and, really map out the skills you need to be aiming for those top-tier roles.
So you can get a model into production. That's great, seriously. But let's be honest, that's quickly becoming table stakes. The real question that senior leaders are asking, the one that matters, is this. Can you build an AI-powered system that's not just cool, but is efficient, scalable, responsible, and actually moves the needle for the business? That's the gap we're going to explore today.
In this slide, it just lays it out so clearly. On the left, you've got the skills that get you in the door, right? Serving models, building a basic RAG, that's retrieval augmented generation pipeline, setting up some simple guardrails. But the stuff on the right, that's the architect level. We're talking about actually creating and adapting models, getting way down into the weeds of optimizing them for cost, and building a strategy that can actually survive at enterprise scale.
So here's our game plan for getting there. We're going to walk through 6 absolutely critical areas. We'll kick things off by moving past the basics into creating and adapting models. Then we'll get into the nitty-gritty of optimizing for cost and speed. After that, it's all about how you fuel your models with real enterprise data, then how to test and deploy strategically, and we'll wrap up with the super important topic of navigating rules and real-world risk.
Okay, first up, the creation layer. Look, just grabbing a pre-trained model off the shelf and plugging it in, that's not going to cut it for long. A true architect knows how to shape, how to mold, and how to customize these incredibly powerful tools to solve very, very specific business problems. And the key concept to unlock this is PFT, or Parameter Efficient Fine-Tuning. Think about it this way. Retraining a massive model with 1 billion parameters from scratch is just insanely expensive. PFT lets you smartly tweak just a tiny, tiny fraction of it. It's kind of like the difference between rebuilding an entire house versus just remodeling the kitchen to be exactly what you need. Much smarter, right? And inside this PFT world, you've got to know the tools of the trade. You'll hear about techniques like LoRa, that's low-rank adaptation, all the time. But it's also about alignment, using strategies like RLHF, reinforcement learning from human feedback, to make sure the model actually behaves the way we want it to. And then there's this really fascinating technique called distillation. Yeah, that last technique, distillation, is just so clever. This slide shows it perfectly. You take a massive, super powerful teacher model and you use it to train a smaller, more nimble student model. The student basically learns all the wisdom from the teacher, but at a fraction of the size. And the result? You get to deploy a model that's way cheaper to run and a whole lot faster without giving up too much quality. And that idea of smaller, faster models leads us right into our second layer, cost. Because an AI system that isn't financially viable, it's just a science project. A huge part of an architect's job is mastering the deep technical tactics that make AI affordable when you're running it at scale. So what's in the optimization toolkit? Well, you've got things like quantization, which is basically shrinking the model's memory footprint so it can run on cheaper GPUs. Then there are decoding strategies that help the model spit out text faster. And of course, a huge one is how you group user requests together. That's your batching strategy. Now, this is a classic trade-off you'll face. Static batching is simple. You wait for, say, 10 requests to pile up, process them, and then repeat. But that can leave your very expensive GPU just sitting around doing nothing. Continuous batching is way smarter. It dynamically groups requests as they come in, which keeps that GPU busy and maximizes your overall throughput. It's a huge lever for efficiency.
Okay, next up, let's talk about the fuel for this whole engine, data. Now, we all know about RAG and vector databases, but in a real enterprise, that is just the tip of the iceberg. The architect has to be the one who can connect the AI to the company's core data nervous system. And that means going way beyond just chunking up a few documents. It means integrating directly with these massive data stores like a Delta Lake. It means knowing how to use LLMs themselves to generate synthetic data when the real stuff is too sensitive or you just don't have enough. And it means using heavy-duty engines like Spark or Write to process features at petabyte scale. So, you've built and fueled your model. Great. Now, how do you actually know if it's working in the real world? This is where we have to move beyond those simple offline accuracy scores and get into the world of active, online evaluation.
And two of the main ways to do this are A/B testing and multi-armed bandits. A/B testing is what you use when you want to find the definitive, long-term best model by splitting your users 50-50. But bandits are more dynamic. They learn as they go and start sending more traffic to the model that's performing better right now, maximizing value even during the experiment itself. But what's really cool is that you can test things without users even having a clue. In shadow mode, a new model gets real traffic, but its answers are never shown to the user. You just compare its performance to the old model behind the scenes. Or with interleaving, you can literally mix search results from two different models together and just see which ones users click on more. It's just brilliant.
All right, now for our final layer. And honestly, this one's a big one: risk. And this goes so far beyond just stopping prompt injections. This is about navigating the really complex world of ethics, legal compliance, and your company's reputation.
A top-tier architect has to think in these three pillars. First, bias and fairness, and I mean actively measuring it and trying to fix it. Second, regulatory compliance. You have to understand big frameworks like the EU AI Act. And third, intellectual property, managing the very real legal risks that come from AI-generated content. I think this quote just sums it up perfectly. Security is all about protecting your system from the outside world. Responsible AI, well, that's about protecting the outside world, your users, your customers, your whole business, from any unintended harm your system might cause. Okay, we have covered a ton of ground, exploring all these key layers an architect needs to own. So now let's put all the pieces together and look at the complete map. This slide right here, this is really the core of everything we've talked about. This is your roadmap. Just notice how in every single category, there's a clear path from the basics to the architect-level skills. So for infra, you graduate from basic Kubernetes to making these huge cost-saving decisions about GPU selection and quantization. In ops, you move beyond just tracing and guardrails to actually mastering online evaluation with A/B testing and bandits. Just take a second and look at this table. This is the journey. So at the end of the day, here's the bottom line. Bridging these exact gaps is what defines the role of an architect. It's about that shift from being a technician who just implements a tool to becoming a strategist who designs a resilient, efficient, and responsible system from the ground up. So, we've laid out the entire map of what might be missing from your toolkit. The big question for you now is, which one of these new territories are you going to explore first on your journey to becoming a true AI architect? Thanks so much for joining me.